Good day, everyone. Another day to live, another day to love, and another day to love. So, for today, we're going to talk about the quadratic equations. In this lesson, you are expected to define quadratic equations and discuss the methods of solving a quadratic equation. But before anything else, let us take a look at our lesson under quadratic equations. We are done with lesson 1.1.1, which is about solving quadratic equation by factoring. Now, we're going to talk about the lesson 1.1.2, which is about solving quadratic equation by completing the square. After understanding the first method in solving quadratic equation, which is factoring, we will now proceed to solving quadratic equation by completing this square. How do you apply completing the square in solving quadratic equation? In the equation ax squared plus bx plus c is equal to 0, the expression x squared plus bx becomes a perfect square when b over 2 quantity squared is added to it. Thus, x squared plus bx plus b over 2 quantity squared is simply equal to x plus b over 2 quantity squared. To solve a quadratic equation using this approach is called completing the square method. Let us now have the steps in solving quadratic equation by completing this square. The first step is to transpose all terms containing the unknown to the left side of the equation and the constant term to the right side only if necessary. The second step is to divide each term of the equation by the numerical coefficient of the x squared term, again if only necessary. This will change the equation to the form x squared plus bx is equal to c. For step number 3, we need to divide the coefficient of x by 2, square it, then add the result to both sides of the equation. Step number 4 is to factor the left side of the equation. This is a perfect square trinomial. Then simplify the right side. For step number 5, you need to take the square root of the expression on both sides of the equation. Write the plus minus sign before the square root at the right side. Step number 6 is to equate the square root on the left side expression to the positive square root on the right side in step 5. Then solve for the first root and then find the second root of the equation. For step number 7, equate the square root of the left side expression to the negative square root of the right side in step 5. Then solve for the second root. And lastly, for step number 8, you need to check each root by substituting it to the original equation. Seems so long? Don't worry, let's have an example for this. For our example, we need to solve the quadratic equations by the completing the square method. Number 1, we have 3x is equal to x squared. Number 2, we have 4b squared plus 8b is equal to 0. And number 3, x squared minus 4x is equal to 5. For our solution, let us first proceed to number 1. Number 1 states 3x is equal to x squared. The first thing we need to do is to transpose the terms in order to form ax squared plus bx. So, from 3x is equal to x squared, we have now x squared minus 3x is equal to 0. Next is, we need to find the constant term that will make the equation a perfect square trinomial. In that case, you need to look at the second term. The second term is negative 3x, and the constant term in that is negative 3, which is the value of b. So, b is equal to negative 3. And our formula is we need to divide b by 2 or simply multiply b by 1/2. That is always the same. So we have b over 2 or simply negative 3 over 2. And after that, to find the perfect square trinomial, we need to find the square of b over 2. So b over 2 quantity squared is simply equal to 9 over 4. How do we get 9 over 4? That is negative 3 squared, or simply negative 3 times negative 3 is equal to 9. Then 2 squared is simply 2 times 2 is equal to 4. With that, let us now solve for the value of x. We have now x squared minus 3x plus 9 over 4 is equal to 0. By extracting square root method, get the square root of the equation. We have now x minus 3 over 2 quantity squared is equal to 0. Simply use the square root sign. So when we square root, or when we get the square root of the equation, the answer is x minus 3 over 2 is equal to 0. Following the steps that I gave you earlier, we need to transpose the constant term. So we have now the final answer of x is equal to 3 over 2. So let us now proceed to number 2. We have 4b squared plus 8b is equal to 0. We need to simplify this equation by simply dividing the equation by 4, since 4 and 8 are both divisible by 4. So let us divide the equation by 4 so that the form will be equivalent to ax squared plus bx. So we have 4b squared over 4 plus 8b over 4 is equal to 0 over 4. So all together. So cancel out or divide it, we have now b squared plus 2b plus blank is equal to 0. Why blank? Of course, we need to find the constant term that will make the equation a perfect square trinomial. Again, how? Simply look at the middle term. The middle term is 2b and the constant there is 2. So the value of b is equal to 2. For our formula, we have b over 2 or 2 over 2, or 2 divided by 2 is simply equal to 1. And when we squared 1, 1 times 1 is simply 1. So we have now b squared plus 2b plus 1 is equal to 0. For that, let us now solve for the value of b. So we have b plus 1 quantity squared, because using FOIL method or the factoring method that I taught you last time, you can find b plus 1 quantity squared to b squared plus 2b plus 1 is equal to 0. So once again, by extracting square root method, you can get the square root of the equation. So cancel out the squared. So we have now b plus 1 is equal to 0. Once again, you can use the addition property of equality or the transposition method. Now, we have the final answer of b is equal to negative 1. Now, let's have number 3 example. For number 3, we have x squared minus 4x is equal to 5. As you can see, this is already in a form of ax squared plus bx is equal to c. So with that, we can have x squared minus 4x plus blank is equal to 5 plus blank. Okay, since the value of c is not equal to 0. So we need to find the constant term once again that will make the equation a perfect square trinomial. So again, the middle term is negative 4x and the value of b is negative 4. So negative 4 divided by 2 is equal to negative 2. Then we need to find the square of negative 2, and that is negative 2 multiplied by negative 2, we have 4. So now we need to add 4 in both sides. We need to add 4 on the left and on the right side. So we have x squared minus 4x plus 4 is equal to 5 plus 4. After that, simplify. So we have x squared minus 4x plus 4 is equal to 9. Then we need to factor out the term in the left side, and that is x minus 2 quantity multiplied by quantity x minus 2 is equal to 9. Once again, when you use the FOIL method or the factoring method, you can find the x squared minus 4x plus 4 in that equation. So, since we have 2x minus 2, we can simplify it by simply putting the square sign. So, we have x minus 2 quantity squared is equal to 9. With that, let us now solve for the value of x. By extracting square root method, get the square root of the equation. Of course, both of them are involved. So we have the square root of x minus 2 quantity squared is equal to plus minus the square root of 9. So since we use the plus and minus sign, the equation will be divided into 2. So again, cancel out this square for x minus 2 quantity squared. So we have x minus 2 is equal to plus minus 3. Why 3? Because 3 times 3 is simply 9. That's why the square root of 9 is equal to 3. Since we're using plus and minus, so we will divide the equation into 2. We have x minus 2 is equal to positive 3 and x minus 2 is equal to negative 3. So again, transposition or addition property of equality. So we have x minus 2 plus 2 is equal to 3 plus 2. Then we have x minus 2 plus 2 is equal to negative 3 plus 2. With that, our final answer is x is equal to 5 or x is equal to negative 1. That would be the end
Both
of our
answers
discussion
are
for
applicable.
quadratic equation by completing this squares. So let's work this out. So you need to solve each by completing the square method. So we have number 1 up to number 6. So thank you for listening and hope you learn from this video. God bless.